Okay, this is going to be the last video for this morning. I saved the last plug connector for the last video, and that is your main power. So this is coming from your generator plug and just instantly plugs into the front left corner of the box here. That's the receptacle for it. So we'll plug power in now, and then we'll power up and give it a run test. Alright, there it is. And you just push it up in there and give it a twist to the right. So that's ready. Let's see, I'm going to walk back over here and kick the 240 volt switch on at the breaker here first. So now we've got power fed to there, and right inside the box here we have a breaker switch. Flip that up. I don't know if you can tell or not, but the PLC is lit up there. On the front panel, there's an HOA switch right here, and then of course the touch screen, which I still have to set up for parameters so that you can enter well-specific parameters into the PLC. So this is auto on this side. This is manual jog, which is for that device over there. And right now you can see the GS1 drive is not lit up with any digits, so it's off. It has to be on auto to run, and this also has to be around here on the PLC. There's a stop and a run switch. Pretty much when you're out in the field, you just leave it in run all the time. Unless you're going to write a program to it, then you put it in stop. But you can also do that from the laptop, which I'm going to fire up right now. So we turn the laptop on. Now I've got all my 5 signals up to simulators. This is the FlowSense switch. And then on this side over here, I don't even know if you can see those. Probably not very well. I have to point this down just a little more. There we go. So you can see the signal splitter box. I've got the Liquid FlowSense connected. We have our e-stop right here, which is fully functional. We have the counter simulator connected up with the other end filter. And these just thread on there. That's all you have to do is screw them onto the connectors that I've already sent to you. And then we have these two. This is my slack switch, and this is my up-hole docking sensor or up-hole stop switch. So up-hole stop switch, slack switch, counter, pressure over here. Over on that side, you can kind of see I've got my compressor set up there and actually plugged in, well, I'll just walk over. So right here, this is I just threaded the pressure sensor into the end of the air compressor hose, and I've got the regulator set on 20 psi right now. So we'll see what we're reading there. Okay, the 2 bolts, I'm using this as a slack switch, and maybe you can see it. This will light up when it comes in sensing distance. This one's got about a 1/2 inch almost of sensing distance. And that whole stop, not so much. For this to run down, the conditions are the up-hole stop has already triggered a reverse mode and reset the counter, and it's ready to run down hole. And the slack switch has to be made at all times or the unit will not run. This is the slack, that's the up-hole stop switch. And of course our counter, and as I run by the counter, I don't know if you can see it, but maybe you can see the light flashing on and off as the key stop passes by the sensor. So everything's up, functional. Let me go over here and fire the laptop up. And as soon as that opens up in about 45 minutes here, sure it's taking a long time or something. There it is. I'm going to drop down here and open the program and click PLC software. So all of my, and then right here it says I'm going to connect to the PLC. You really don't have to mess with much of this unless you have to reload the program or something on a new PLC later, then you will. So you hit connect to PLC, and it'll come up the IP address for both the this laptop and the IP address for the CPU and the control panel. We're going to hit connect right here, and it allows you to read the program that's on there right now, and that's what I'm going to do. That's the program that I'm working on. So I'm going to hit OK. I'll open that up, and it's in run mode. I'll expand this window here. We're going to turn the status monitor on. So now we're going to let's watch it run. So pretty much this thing's ready to run by itself and automatic, and it's going to simulate running down the well first. And our sensors are both on, so we're uphole. Incidentally, realistically, if you're in the uphole position, then this would actually be off. Because what happens when the canister comes up the hole, the switch is on, and it pushes a spring-loaded docking head upward, and when it does that, it moves the sense device, or the metallic device in front of the sensor, off of it, and that's what stops the drive over here from running. So we'll come over here and turn on the HOA switch to auto, which is to the right, and I've got to get all this labeled like I did I did get the manual controller labeled and put some polycarbonate over the labels and whatnot. So now the brake power is on, and then the motor starts. So we apply power to the brake through this box to your brake on the motor, and then the motor starts. So power to the brake, release the brake, start the motor, and then we start running down the hall. And you probably can't see the counter. If I scroll down here in the program, not there. Jeez. How about right there? Okay, what I did is I have the maximum depth right now set at 600 feet, and I'm running the motor at a pretty slow. We're running at 17 hertz actually, and we're at 400 feet. So it's gonna cut off here in just a second. So what will happen is the motor's gonna coast because it's not connected to a gearbox, so it's gonna coast. And we're at 530, 40, 50 feet, just about ready to. So the first thing, we'll stop the motor. Okay, the motor's off, 0 hertz. Then the brake removes power from the brake and locks the motor with the brake, so it can't free fall any further. And that coasted past about 17 counts. Release the brake, put it in reverse. Now we're coming back up the hole. And the way I've got the way I'm set up right now is 50 foot. Right now we're counting back down from 600 foot deep, and we're back up around 460 feet deep on the counter. So when we hit 50 feet, you're going to see this drop from 17 hertz. Well, you can't see the box that well unless I tilt this up a little bit. There we go. Anyway, the drive will drop the speed down on the motor. Maybe you can hear it and see it. That light's not a lot of help, is it? It's a bright LED light. But everything is functioning and running by itself in automatic. So we're at about 160 feet back up the hole now, still running. And approaching. I should have made the depth much less, it would have shortened the bleed up a lot, but we're almost done. Okay, see, we just slowed down to 5 hertz. You probably can't read that over there, but we're setting at 5 hertz. And then we'll do that until we're at 23 feet. So we're coming up the hole, and we're going to dock slowly. And once it gets up, this comes off the uphole stop switch, stops the unit. And the unit's going to time out, go back down the hole. Actually, the pump would kick on at this point, which I haven't programmed in there yet, but that's a rack. And then send it back down the hole. And of course, when that happens, this will come back on. So the uphole stop switch is on. The slack switch is on. Now, if we get slack, we just stop it, and then we'll take power off the brake and lock it. And then as soon as you put the slack back on, the tension comes out of the cable. The unit will time out and start back up down the hole in the same direction. So all of that functions through the Modbus communication cable perfectly. It does it every time without fail. And that was probably our most difficult thing last time we did this a couple of years ago. So all that's working great. So I'm very close to being able to ship this, but I do have some programming work and some user interface still to go. So that's where we're at, and I'll conclude this video, and I need to head to work over to Odessa. So y'all have a good day.